Okay, we're going to look at some problems here today from section 3.1, solving quadratic equations. And we're going to look at three different methods, graphing, factoring, and using square roots. So here, it asks us to find, or actually solve this equation. What that means is that we're going to set it equal to 0. And we're going to solve this equation by graphing, which means we're going to find what we call the zeros or roots. Those terms are synonymous, and if they are real numbers, and soon you're going to be learning about something called imaginary numbers, if they are real, then they also represent x-intercepts. And there's a way to do this on our calculator, and we've done this in class, but we'll go through this again here. So we're turning on our calculator. We would have been in our home screen, so we'll hit y equals, and we're going to enter our equation, 3x squared minus 18x plus 20, and then we're going to hit graph. So there's our graph. Now, solving by graphing is on our calculator is usually what we want to do, especially if we have what we call irrational roots, which means that our original quadratic equation is not going to factor, and rather than use the quadratic formula, we're going to, or even completing the square, which we could actually do here, which we'll talk about how do we do that here. We're going to do that on our graphing calculators. Okay, so we see that we have two roots, one here and one here. We're going to find each one of them, and our calc screen right here, so we're going to, it's in blue, so we're going to hit second, calc or trace, and then the 0 is what we're looking at. So we're going to go down to 0 and hit enter. So just like we did in class, there's a series of commands here. The first it says is left bound. And what that means is it wants you to tell the calculator where should it be looking. Because there's a whole infinite number of x values here that it could be looking at. And so you're going to tell it to look for this one, and you're going to give it a left boundary. So I see that my x value is at 0 right now, so I'm going to move it to the right till it gets closer. So notice there is the cursor. It's at a positive value, so that means for this root, it's to the left, and I'm going to hit enter. Now it wants a right bound, so I need to move that cursor to the right. So I only have to go 1, and you can see that it would be to the right of the cursor. Our y value is negative. So we always have to have a positive and a negative y value so that we are on either side of the root, and hit enter. And notice also here you have the two arrows, one pointing to the left, one pointing, or to the right, one pointing to the left. And those are the boundaries. Now it wants us to guess, and this is going to be the first x value your calculator, which is a computer, picks in order to be able to solve this. And so I hit enter. I can just use that boundary as a guess. And there is one of the zeros. And you can see the number seems to at least go on, and it does. And so in writing that, we're going to go to 3 decimal places. And so one of the roots, one of the solutions, one of the zeros is at 1.472. Again, going to 3 decimal places. Okay, so now we want to find the other root or other zero or other solution. So we're going to do this all over again. So I go second, hit the trace, which gets us to the calc screen, 0. So now I want to move the cursor so that I am to the left, okay, of this root. If I go here, notice there's cursors to the right of that root of that x value. So I'm going to go back, so I'm to the left and hit enter. Now it asked me for a right bound, so I'm going to move to the right, and I can move a little bit more, doesn't matter. And then I guess I just use either boundary, or I could move it closer. And there is the second root. Now, we're going to go to 3 decimal places, so we have 4.52. Now, you can either truncate, which means that you don't worry about what comes after the 3rd decimal place, and that would be 527, or If you want to round, then we use the number to the right. Since that's 5, anything 5 or greater, we would round up, and you get 4.528. So either way, you end up with your 2 roots there. Okay, we'll leave completing the square to another day. So now let's look at factoring. Okay, so here we have a leading coefficient that's not 1, it's 5. The fact that it is prime does make guessing and checking, if that's what we were going to do, a little bit simpler. But I'm not really a big fan of that if I can avoid that. So we're going to use our splitting the middle and grouping. So as a review, we're looking for 2 numbers that add up to negative 17, that coefficient of x, our middle term, and 2 numbers that multiply to the product of a and c, or the leading coefficient and our constant term of 30. All right, so they have to multiply to a positive number and add up to a negative number. So we know both numbers have to be negative. And so when we look at our factors of 30, and not that we would want to list them all, but there they are. Whoops, I wrote 2 and 30, not 2 and 15. So there's our factors. So some combination of those has to add up to negative 17. And so we should see that that is negative 15 and negative 2. And the order doesn't matter. You can write them in either order. So here's our splitting the middle. We're going to take the middle term and split it. Instead of writing negative 17x, I'm going to write negative 15x minus 2x. So I've split that middle term, and here's what we call our grouping, and we're really adding those. Right? So grouping is just using parentheses. So I'm going to factor this second grouping, and out of the negative 2x and the 6, we can factor out a negative 2, and we're left with x minus 3. So what we know now is that this grouping has to match that grouping. This has to be x minus 3, and in order to be left with x minus 3, we're going to factor out a 5x. So now look, we have 5x and x minus 3, negative 2 and x minus 3, so the term in common in both of those is x minus 3. So we factor that out, and we're left with 5x minus 2. So there's our factoring, again using splitting the middle and grouping. Now we use our zero product property. Take each factor, set it equal to 0, and we end up with 3 and 2/5. So there's our 2 solutions to this quadratic equation using factoring. Okay, let's look at some square roots. So when we're using square roots to solve, what we want to do is isolate the variable. So here we're going to subtract 5 from both sides. 3x squared equals 36. Divide by 3. And x squared equals 12. All right, so we've talked about this in class. Our next step is taking the square root of each side. And one of the things in middle school, many times you're taught that this equals a plus or minus. What we've learned is really that's not true. By definition, and a little side note over here, the square root of any number, I'll just call it c, where c is greater than or equal to 0. We don't want to worry about imaginary numbers right now. This, by definition, means the positive or principal root. So that is just the square root of 12, which we'll talk about simplifying. The other thing that we've learned is that by definition, the square root of x squared, or any quantity squared, is the absolute value of that quantity. So now we know the square root of x squared is the absolute value of x. So this is truly where your 2 solutions come in. When we solve absolute value equations, we set x equal to the positive and x equal to the negative. And then simplifying this, square root of 12, right? 4 is a factor that is a perfect square, and we're left with 2 root 3. So we would simplify this to 2 root 3 and negative 2 root 3, or you could write it as x equals plus or minus 2 root 3. But this is really the critical step here in this problem. What we don't want to do is write that, we don't want to write that the square root of 12 is plus or minus, because that's not correct. Again, we know that means the positive or principal root, and the way we get two answers is using this. So we can apply that here as well. So we're going to add 8, we're going to isolate the variable. That's 16. To get rid of the 1/4, we'll multiply both sides of the equation by 4. So now we have actually we've isolated that whole expression, that whole quantity. So now to undo that, we'll take the square root. And so on the right side, again, positive or principal root, this is the absolute value of that quantity. So we're still applying that rule, that definition. And now our two equations will be x plus 2 equals 8, x plus 2 equals negative 8. Subtract 2, we get 6. Subtract 2, we get negative 10. And there are our two solutions. So again, big key for this year is recognizing the square root of that quantity squared is the absolute value of that quantity. So hope that helps you with 3-1, and we'll see you soon.